Assalamualaikum and good morning to our lecturer Nur Akmal BT Muhd she is our lecturer for the environmental science case study. My name is Muhd Nur Akmal Dharul with a matrix number 01DSB18F2026, and I'm from DSB 4A. And now I'm going to talk briefly about my building, which is the pixel building, which is more to green building itself. And now I'm going to show the contents that I provided in this case study, which includes the introduction, the building description, important features in the project, and that includes 4 topics that we have learned in environmental science, which is thermal comfort, ventilation, lighting, and acoustics, renewable energy, sustainable building, 100% fresh air, gas-fired absorption chiller, and last but not least, the suggestion and conclusion. Now I'm going to present about the introduction. So as you can see, this building is located at Melbourne, Australia. So this was completed in July 2010. The client is Grocon and the former architect is DBA. Pixel is also one of Melbourne and Australia's most significant and ambitious projects. This building scores a perfect 105 Green Star points and 105 LEED points. Pixel is also one of Australia's first carbon neutral office building, generated at its own power and water on site. The Pixel is known for its future office, which is a prototype of commercial buildings that emerges when a carbon-constrained environment demands a greater focus on energy efficiency. Now, why is this building chosen as one of the most greenest buildings? So, actually, from what has stated from the website, the Pixel building project is a 4-level building in Melbourne, Australia, with an impressive array of sustainable design technology and innovation. The client also, in my opinion, had an ambitious goal for Pixel building to become Australia's first carbon neutral office building. So the solution supported the building by generating its own power and water through on-site wind turbines and a green roof, which uses evapotranspiration of grey water from the building. This is also designed to be water balanced. Pixel building can disconnect from the main supply and be self-sufficient for all its needs, excluding occupant drinking. Now, to reduce the Pixel building's carbon feature that I see added to this building, the design employed low carbon concrete, which is also known as Pixelcrete, which you can see by the building that has various of colors of red, green, and yellow, orange, and recycled sustainably sourced building material. Now, based on what I explained briefly from the introduction, that this building achieved a perfect Green Star score, which it achieved 105 LEED points. This is the award to this building, and it's having a new era of sustainable infrastructure in Australia. And also, this building used more than 30 innovations, and that is what the points are for. It also goes above and beyond the norm in green building innovation, redefining the way buildings will be built in the future. And one of the greater demands and advantages of this pixel building, they reduce energy demands from aircons, from fans, and they use more of natural ventilation that has been provided around the site. This is focused on energy efficiency in the facade and services to minimize the energy required for lighting, heating, cooling, and ventilation. So from what I've studied for this building, it reduces energy demands not just from ventilation. It also includes lighting, heating, and cooling, which like I said, this is one of the greater advantages in terms of energy usage. There are more advantages to that, which includes great green ideas, zero carbon facility, energy self-sufficiency using a unique cement, with introducing Victorian grassland species, and rainwater harvesting and water self-sufficiency. So about the green ideas that they have implemented in this building, well, the idea in producing the pixel was to suggest a prototype office for future that is capable of tackling the issue of carbon effectively. It's quite a small building actually, with a gross floor area of only about 1,000 square meters. Yet the innovations it incorporates can give a new face to a sustainable building industry. Zero carbon facility. The pixel as a building is carbon zero, which means that all the carbon generated annually for running the facility is offset by renewable energy. A new process of carbon neutrality was also introduced. So all the carbon embodied in the materials used in construction is also offset through the use of renewable energy over a period of time. The building is capable of delivering a net carbon benefit to the environment over its full life cycle. Now, to the energy self-sufficiency, like I said, this is more related to the second advantage that I have explained, which it reduces energy demands. The pixel produces all of its energy needs on site. The first source comes from an extensive photovoltaic array on the roof, which is mounted on a tracking device to improve the output by nearly 40%. The second source comes from very efficient 1 kilowatts wind turbines. These two sources help the building generate more electricity than it actually requires. So this building, it also uses a unique cement for the floors of the building. Going to move on to the building description. So as you can see, the image below shows the shading and sun during estimated time of the day. So as you can see, there are 3 diagrams. So as you can see from diagram 1, the sun is transmitted through the building of a tilt in 18 degrees. So the second diagram, it shows the sun is tilting from 30 degrees transmitted through the building. And the third diagram, it shows 65-degree tilting towards the building, which also brings us to the thermal comfort. This explains how the window of this building reduces heat and lighting to the building. It has an glare control panel to ensure thermal comfort. The window is also a rotatable 180 degrees shading glare windows, which means this window is rotatable of about 180 degrees to ensure enough ventilation to be transmitted to the building. The photovoltaic panel and wind turbines on the roof were designed to capture power